Yes, hi, welcome everybody. Thank you for joining our webinar today. We have got a list of contributors on a very fascinating topic. So my name is Finlay Colville and I'm Head of Market Research at PV Tech. And our webinar today is entitled Building Sustainable Solar Manufacturing Facilities in the US. So we've got three contributors. Today I'm going to be doing the moderating and asking some questions and probably coming in with some ideas on and off. We're going to do three presentations, they each be about 10 minutes, and there's a chance to ask or lodge any questions. For those that are listening live, I apologize for those that are currently listening to the recording. Clearly, you will not be able to ask questions, but hopefully you'll find it very interesting. We'll try and get through the questions. You can do that through the questions, the tab at the bottom right on the screen. And again, just feel free to ask anything. Try to ask the questions before the very end, because it's kind of hard to read the questions right at the last minute when they come in. So we have three presentations, and it's in the order you see on the screen here. Michael from Ultra Low Carbon Solar Alliance, Mark from Clean Energy Associates, or CEA, and Marco from Bottero. And I'll let each one of them say a little bit more about what they do and what their company does just before they dive into the presentation. So the webinar here really is trying to address, there's a few things going on here. One is, everything's on the back of, what we anticipate happening in the next few years regarding manufacturing within the US, not just modules, but for cells and wafers, and broadly building out that ecosystem in the US. And then the two parts here that are most relevant is the word building and the word sustainable. So we're going to hear, what does it mean to actually build them, as opposed to talk about building them? Who's going to build them? How's that going to happen? What's the process? And also sustainable. Sustainable not just from the perspective of, will the factory be around a long time, but does it have a supply chain of equipment and materials that pretty much passes all the requirements for ESG and building materials? So I'll stop there, and I will invite Michael onto our virtual stage. And Michael is going to give our first presentation. So Michael, this is all yours, man.
Thanks very much, Finlay, and I appreciate the opportunity to join you all. So I'm Michael Parr. I lead the Ultra Low Carbon Solar Alliance, which is an association of PV manufacturers across the supply chain from poly through module, who are seeking to create a lower carbon, more sustainable solar supply chain, both through their own manufacturing practices and through collaboration with downstream market participants. I'm going to turn my camera off here so you can focus on the slides. And what I'm going to do is give you some broad background, kind of scene setting, and then dive into some of the specific challenges that are facing manufacturers in the US at the moment, and some strategies for how you deal with those challenges if you were looking to create or expand manufacturing here in the US. So I think most of this is going to sound very familiar. The demand for solar is growing sharply and will continue to do so well into the next decade. A lot of people in the world want a lot of PV. There's also a growing awareness about some challenges in the current supply chain that is causing buyers to seek to reduce exposure to some of those risks, like high carbon emissions, forced labor, and some of the supply disruptions that we have seen, whether it is from manufacturing challenges in East Asia, shipping and logistics issues, or policy interventions. They've all created significant disruptions in supply. There's also, at a higher level, just growing geopolitical tensions between the West and China, increasingly China's seen as a strategic competitor, and there's growing concern about the high level of concentration of the solar supply chain in East Asia and what that might mean for strategic relations. Of course, there's been a lot of ink spilled about the Inflation Reduction Act, and I think the key thing there is it's driving both U.S. manufacturing and U.S. deployment, and it has additional incentives for domestic content, which is a further spur. You will be generally familiar with the DOE Loan Program Office, which is helping provide capital to companies in this space who might otherwise have some difficulties getting their hands on capital. And some elements of this supply chain are pretty capital intensive. And in general, we're seeing greater attention to carbon footprint and sustainability, and buyers seeking, in addition to just more resilient supply chain, seeking a better supply chain as they go. And then a major buyer here in the U.S. has been kind of wrapping all this up as buyers seek to de-risk their supply chains, both assure greater access to modules as well as help to drive more sustainability up their supply chains. They're using their purchasing power through long-term agreements and upfront payments to invest in U.S. manufacturing capacity, and I'll talk a bit more about that. Just a word on carbon. There is a very distinctive carbon footprint advantage for PV manufacturing in the West versus China at the moment. That gap will narrow over time as the Chinese grid continues to decarbonize. But at the moment, for companies who are either eyeing things like the carbon border adjustment mechanisms that have gone into effect in Europe and are coming to the US, as well as their own Scope 3 carbon emissions goals, there is a distinctive difference in carbon footprint that is increasingly attracting market attention. There are, of course, a host of policy drivers as well. One of the longest standing, now probably about 15 years on, the French government has had a carbon footprint standard for PV tenders into the public grid. And the way it works, there's a threshold for carbon footprint above which you can't even bid a module into the system. And the lower you are below the footprint, the more attractive the payments and scoring on the proposals are. To implement this, the French have developed and then regularly updated a pretty detailed technical approach for calculating its carbon footprint. I mentioned again the IRA, which is driving both manufacturing and deployment, and that deployment is increasingly seeking domestic, so there's a nice further feedback loop for domestic manufacturers. You will be familiar as well with the Uyghur Forced Labor Prevention Act, which has really started to limit the import of some PV products that cannot demonstrate with great clarity that they are not in some way tainted with forced labor, particularly in the Xinjiang region. And the EU is moving down this road as well, having proposed to give EU member states similar authority to block imports of products that were made with forced labor. And that is sort of in the administrative process at the moment. The EU is beginning to implement a carbon border adjustment mechanism, and there is bipartisan motion in the US, particularly in the US Senate, to look at carbon border adjustment mechanisms as well. I think in part there's a recognition that the US is a carbon advantage place to manufacture. And then I think at a very macro level, having watched the use of essentially a lock on energy supply as strategic leverage, as Russia has done with Germany and others in recent years, it has really gotten policymakers and businesses' attention. It's caused a great deal of disruption in energy markets, particularly in Europe. And I think there's growing awareness that we face kind of a similar situation with solar, and China has shown itself willing to use clean energy as a geopolitical tool in the past, and I think that focuses people's attention. All right, I'll just get through this real quickly to preserve time. Increasingly, we're seeing private sector seek out more sustainably manufactured solar. Developers like Lightsource and Silicon Ranch, the utilities, developers, and corporate buyers in the Clean Energy Buyers Alliance are increasingly trying to drive higher levels of sustainability in both PV manufacturing and deployment. And the US government has now established EPEAT registered low carbon PV modules as required to be used in government purchases of modules, in PPAs and energy savings performance contracts. And EPEAT is a sustainability low carbon eco label for PV. So for manufacturers, what are some of the challenges we're seeing in the US? Many of these are not unique to solar, but there's been a big growth in manufacturing in the US, and that's creating strong competition for suitable land for either greenfield or brownfield development. If you are just looking to lease a building, less of a challenge. Strong competition for labor, both skilled and unskilled. And because we have not done some of these more specialized areas in the US, like ingot, wafer, and to some degree cell in recent years, there's a lack of experienced personnel to help establish new facilities here. We are definitely seeing challenges in supply of construction materials. Mark, I'm sure, will speak more to this, with some items like transformers having particularly long lead times, and this can affect the pace at which you can stand up a new facility. Some of the new market entrants or smaller market entrants are having some challenges with capital in our current high interest rate environment. And this is both at the federal and state level. There are a number of Chinese manufacturers who are appropriately enough eyeing manufacturing capacity in the US, and there is, for better or for worse, genuine political resistance to taxpayer money, whether it's IRA incentives or state economic development incentives, going to Chinese-based companies. And that's just something that you'll have to navigate. Another element is whether your domestic supply chain will scale fast enough to meet your growth goals. And then, of course, all of the industry is dealing with the price suppression we're seeing from high levels of manufacturing overcapacity in East Asia. All right, so what do you do about these things? How do you manage them? I think one of the most effective tools we are seeing is a high degree of risk and incentive sharing along the supply chain through strategic partnerships and long-term supply agreements. We're seeing this with developers signing multi-year supply agreements with module makers, with upfront front-end loaded payments to help capitalize new capacity. We're seeing it further up the supply chain as well. If you look at the Hanwha Qcells REC Silicon long-term supply agreement that basically helps finance the upgrades and restart to the REC Silicon, Moses Lake Silicon plant, and also starts the beginning of the first truly vertically integrated company supply chain in the US. I also think we're going to see, particularly for folks looking at wafer, the co-locating with upstream suppliers like Poly makes a lot of sense. There's a lot of energy and other integration you can do with those facilities. I mentioned the buyer's role in long-term supply. Definitely seeing my members collaborate closely with local community colleges and engineering schools on workforce development, not just now, but into the future, because I think everyone expects these facilities to expand over time, and they're going to need more trained staff. A number of my members and other PV module companies are looking to differentiate themselves in the market by meeting the criteria, the EPEAT Eco Label, to demonstrate in a very simple way to buyers that they are sustainably manufactured product. And if you are one of those East Asian companies looking to invest in the US, seeking ways to ameliorate some of those political current concerns, such as partnering with a US or EU-based company, and demonstrating that most of the profits generated from the business will remain in the US and be reinvested here, can go a long way to quelling some of the political pushback you might otherwise experience. So thanks very much. And with that, I will turn it back over to Finlay.
Yeah, Michael, just one or two questions before we dive into Mark's talk. Can you say a little bit about, you showed the graphic in terms of the low carbon footprint comparing China to Europe and North America. What's driving those big differences?
There are probably three major differences. The first is simply the grids that the businesses are drawing their power from. And as you know, some elements of the solar supply chain, particularly upstream, MGS, polysilicon, and wafer are all quite energy intensive. And the Chinese grid is still about double the carbon intensity of the US grid because it's still the high proportion of coal in that energy mix. We also see a lot more focus, frankly, on energy efficiency among some of the Western producers because energy is a bigger part of their cost structure, and so they're financially motivated for energy efficiency. And then lastly, I think we have better developed PPA structures in the West where you can buy renewable power in a transparent way that market structure is not nearly as well developed in China. There's still a lot of hindrances to broad scale use of PPAs across regions and such in China. So I think those are really the three major drivers.
Yeah. Okay. So the the most energy intensive parts of the value chain is making polysilicon and pulling ingots. So is it the case that that low carbon footprint delta is going to be less pronounced to begin with if on day one, and day one, let's say being 2024, there's still a lot of cells having to come in from Southeast Asia. It's assuming, the polysilicon can be coming from Germany, it can be coming from Hemlock shipping it over to Southeast Asia for it to come back in as cells to the US. So on day one, it's definitely not as pronounced, but those graphics there are assuming that you've got everything being made in the US.
That's right. And so I think the carbon contribution is spread somewhat front-end loaded, spread fairly evenly across the supply chain these days. And so you can, for example, if you are buying Western poly, making it into wafers and even cells in Southeast Asia and coming back and doing your module assembly here, you'll still have a pretty good carbon footprint. If you are buying Chinese poly and making wafers in Southeast Asia or China, you're still going to have a pretty high carbon footprint. And so it's we are hoping to see market demand for low carbon solar create more confidence in the poly guys, whoever they are, to invest in more capacity in lower carbon environments, whether that's North America, Europe, Brazil would be a lovely place to make poly. There are lots of opportunities for lowering the carbon intensity of poly currently.
Yeah, and just finally on you spoke about the whole sustainability part. Is that something that's more kind of subjective? There's not clear metrics other than a kind of box ticking at the moment in terms of satisfying buyers. Is again, is there some kind of, is there like a guidebook? What defines sustainable?
So, I think we all know that both in US and Europe, the solar associations, which fundamentally represent the buying end of the market, have their sort of supply chain transparency criteria for about, with varying degrees of rigor. But those are voluntary approaches. There is an ANSI standard for sustainability and low carbon in PV that was developed in a multi-stakeholder voluntary consensus process, is very rigorous and transparent criteria, and is third-party verified, and that's the EPEAT Eco label. And so it is, in fact, a very rigorous standard, and requires, supply chain auditing. It requires detailed demonstrations of your bill of goods, requires your module to be disassembled by an independent lab, and the bill of goods, particular modules confirmed. And so it is a very rigorous standard on sustainability, which is why folks like Silicon Ranch and LightSource are already using it in their sourcing here in the US.
Yeah, I have this phrase I've been using for years, way before ESG was a term. And I used to always say it to people that the most important thing is to know who makes what where. And I always keep coming back to it. And that literally is my, I think it'll be my mantra for the next 100 years, who makes what where. Michael, thank you. We'll bring you back in at the end for some team Q&A. So next, I'd like to invite Mark to our virtual stage. And I'm going to just pass the floor over. Mark, just introduce yourself and CEA for those that may not have ever heard about CEA. It's all yours.
Absolutely. Thank you, Finlay. So my name is Mark Hagedorn. I'm the Vice President of Manufacturing Services for CEA, which stands for Clean Energy Associates. We are the clean energy arm of a much larger company that you probably heard of called Intertek. It's the world's largest ETL outside of China. And so our company focuses on end-to-end services for the clean energy sector. So if you're doing something with solar, something with wind, something with storage, green hydrogen, from market intelligence to supply chain to QA/QC, engineering services, and then e-mobility, and then my business unit, manufacturing services, we have something to offer you to help you out. Now, my business unit, which is the relevant piece here, if you got what we did put on a T-shirt, is we build gigafactories. Now, we're not necessarily pouring the concrete and welding the steel, but we're helping with feasibility, incentives, finding a site, helping you manage the design, the construction, the equipment, the organization build out, then ultimately the commissioning, and then we have some service offerings for continuous improvement, traceability, that type of thing once you're up and running and have ongoing operation. So that said, I'll jump into our presentation here that I think builds nicely on Michael's low carbon presentation, and touches on some of the same topics. So certainly the reason to do domestic manufacturing is in the U.S. is pretty clear right now if you're involved in this industry, either as a customer, an investor, or an actual manufacturer. So with the UFLPA and the anti-dumping, anti-circumvent items with Customs and Border Patrol, to some of the other government incentives that are available either through the IRA or some of the other programs, and then the fact that local manufacturing, so putting the Made in the USA sticker on your product gets you premium pricing. Those are all really important things, and so the value proposition for the domestic manufacturing piece is it's really there, whether you're concerned with the global events piece or profitability. That's all clear. So then once you've decided that you want to manufacture domestically in the U.S., then you have to pick a site, and there's lots of things to consider. I mean, a couple of the high points there are, what's it actually going to cost in a given location? Does that location give you an advantage with finished goods and access to markets? Is there a friendly regulatory environment? Especially as you move up the solar supply chain into cell and ingot and wafer. There's some chemicals involved there that need to be considered. Is there an existing workforce that you can build a self-refilling workforce funnel from? Is the infrastructure there? Is there and transportation and utility availability? What makes this kind of challenging and a daunting process for some people looking to place a factory is there really isn't a standard methodology out there that you can look on the Google to find where to put a factory. The incentive landscape, there was not really a manual for that and how to develop those and who to talk to. Depending on which state and which entity in the federal government that you want to speak with. Again, there's not really a roadmap to that. And then you're sort of forecasting the future a little bit with how regulations are going to change, how the market's going to change, how the finances work. And so that's where we bring a standard process to the table. So yeah, between the different industries that I mentioned, there are some different dynamics, but generally under the clean energy manufacturing umbrella, you have to look at what incentives are available, and that's not the most important thing, but it's a very nice to have. What are the important things are the costs that you can't get away from once you site a factory somewhere. And so I used to say that was logistics costs and labor costs. Now, in especially where this kind of dovetails into low carbon, it's your utility costs, specifically your power costs, that can also be a thing. And an example of that is that if you have as a lot of these manufactured commodities work, is that there's not a completely domestic supply chain available everywhere in the USA to place a factory. And likely, if we pick on solar, you may be challenged with having to get glass and potentially cells for some period of time from an overseas source, which means you have a lot of inbound logistics for your raw material. And so if you're a 3 or 4 day truck drive away from a deep water port, and say that costs $1,000 a day, and it's not really how pricing works, but it's conceptual, then the guy that's four days away from his deep water port is going to be way worse advantaged than the guy that's 1 day away from the deep water port. And then if you look at how many trucks you might have in your 5 gigawatt or larger manufacturing facility a day, which could be 50. A lot of the incentives that you might have gotten for being 4 days away from the deep water port in a given state are offset potentially in the first couple of days of operation. And so that's where the sustainability aspect comes along. And so when we talk about sustainability, there's the low carbon aspect is important, but in the factories we develop, we're also concerned about them being around 5 years, 10 years down the road, especially when some of the incentives begin to sunset, which just means you have to be really efficient with your operational expenditure. And a lot of the root of that, kind of I was building to here, comes down to the site you select. Labor costs are the same way. If you have to do the Field of Dreams thing and i.e. build it and they will come, that's one of the most expensive ways to build a workforce ever, and often not sustainable, because you'll have to keep doing that ad infinitum and paying relocation and all of those things. So really, you want to start with a really good workforce base that then you can work with the various educational institutions around you to begin to refill, become a premium employer, so where you can attract employees on their own, and get to that self-refilling funnel. That's the most efficient way to do that, and again, affects your operation costs, especially if you start looking at what it costs to replace an employee. It could be $3,000 or $8,000 per employee. How many employees do you have? How often do you turn those over? it gets expensive very quickly. And then on the other side of things, if you have a very expensive utility environment, that affects that bottom line and how operationally efficient you are. The regulations that isn't an everyday thing that you have to deal with necessarily, but certainly affects the development of the factory, and then a lot of your process and procedures as you go through things. And then there's political security, insecurity. I mean, you see in the news, you talk about red states and blue states. We're completely agnostic as far as that goes. We look more along lines of how big of swings and volatility are there in the state and local government, and as to whether incentives will be there, will the government be there to support and develop things with you as you grow. So all very important. A great example of the next piece of sustainability is you want your supply chain to develop around you. Like we talked about, a lot of these supply chains are going to start off being foreign and develop over maybe a 1 to 6 year period to become domestic around you. And so that means that you have an ecosystem, and you site your factory in an area that has some of the components already that you need, potentially some of your competitors nearby, as well as some other complementary industries. And for those of you guys that know me, I have a bit of a background in automotive, and so one of the great ecosystems in the U.S. is the automotive ecosystem around Detroit. And so not only do you have various manufacturers sited there, they have all of their suppliers for whether it be steel stampings, glass, rubber seals, even nuts and bolts. They've all sort of congregated around this one area, and it makes their operational costs are very efficient. Now, this goes through our trade-off procedure here, where you have some sites that are better than other sites for various reasons, but if you actually go and look at it, if you get a really cheap deal or possibly free land somewhere in a place that's far away from a port and doesn't have a workforce, that site may be more expensive for you in the long run than the low cost upfront site. At the same time, you can find yourself in a site that is very near a deep water port and has an amazing workforce, but is in a heavily taxed, high-priced real estate area that may also make it not quite as competitive as another site. So, and we really like this slide because it shows all the different balances and trades that you go through in finding the site and developing. I won't read through this whole slide, but these are some of the finite details that you evaluate when you're looking through the site selection process for given industry, and then ultimately get that selected. Once the site's selected, we have a pretty standard process that I think Marco's probably going to go a little bit further into, as far as the construction phases of the stuff. But the big phase for us, and really setting yourself up to be sustainable, is that first phase of feasibility and site selection. Once you've got that done, then there's best practices for building a solar or storage facility that we certainly help quite a bit with. Getting that equipment in there, making sure everything's on time, on budget. As Michael had mentioned before, a couple of the longest lead time things that you have to deal with in your planning are not something that you think about it. Maybe if you're building batteries, maybe it's your slot die coder, but it might be something a lot more pedestrian, like your roofing membrane or the transformers for your substation. Those may actually be the longest lead time things that you're working with. And so, one of the most expensive, least cost efficient times in the factory development is basically the phase 3 as we have it up here, which is commissioning. And if you've gotten your timelines wrong and you've not accounted for some slip in there, when you're commissioning the factory, you have all your OPEX online, you have all your CAPEX online, all your whole workforce is there, the lights are on, but you're racing to produce certified and saleable product. And if things are missing, i.e., like say your transformer, so you don't actually have power, you have all that stuff sitting there doing nothing and going burn it through your capital. So that's one of the other very, very critical parts in developing these factories is getting that commissioning period to be tight and completed on time, on schedule. And then once it's up and running, you got to maintain all that stuff. You got to continuously improve. You got to keep the CapEx down because again, the incentives, they don't last forever. And in order to really be sustainable, that's how we view true sustainability is, regardless of all other influences, can you continue to operate at a profit? And that's how we get there. So I thank you guys for your time and letting me talk to you all about that. And I'll turn it back over to Finlay.
Mark, great. Yeah, so just stay on for a minute. Is there any issue at the moment with the cost of capital? Everyone moans on and off about cost of capital and finance, and in particular, significant moaning going on around the world with interest rates. So where does that factor in?
So, I'll actually kind of steal a quote from one of my previous CEOs that I tend to believe is that if you have a really well constructed and defined project, you can get money anywhere. I mean, what it costs you. The difference between a good deal and a low deal, or a bad deal in cost of capital, percentage wise, that's not. There's not necessarily a big range there.
Right.
If you have
Agreed.
if you have a really well-defined project, you could get the best interest rate possible. What you're really looking at, from my standpoint, and keep in mind I'm chief operations guy, right? Is that what does that money come with? And this gets into that ecosystem space that I talked about in my slides, right? Is do they have access to other investors? Do they have access to the supply chain or the customer base that you'd like to have? That to me, that's really the true cost of capital. And there is, a bag of money is great, but when you're putting one of these factories together, it takes an ecosystem or a village to make it all happen. And that's one of the great ways to build that.
Yeah, I haven't even got into asking, is the money clean? And let's just not go there, or maybe nothing will ever happen. What would you see, just again on the kind of the money side? What's a period for let's say a new module factory, or selling module factory? I mean, is this something that is going to how long until you get return on investment? Is it 5 years, 10 years?
Yeah, so most of the projects that we're looking at that have a good defined supply chain and a good process to domestication, which means you got to get some of that logistics cost out of there, it is about 5 years. And the development time on that project, the best that we could ever possibly see with some of the lead times, especially for equipment, as it were, is about 9 months in the U.S., which can be a little bit shocking to some of our overseas factory developers that can prop up a module factory in 5 months. And so there's a little bit longer of a lead time in the U.S. domestic market, but that also gives you some more time to sort out some of the other things that are maybe a rush or a crash. If you really were in that kind of low lead time range.
Yeah, and just lastly, how many workers would be employed in a gigawatt factory?
So a gigawatt's kind of the minimum building block that we fool around with at CEA these days. Just with the massive activity that's going on out there in the market. For a solar module factory, 3 to 5 is probably the more the sweet spot where you can leverage some economies of scale in there. But per the 1 gigawatt to 3 gigawatt building blocks in that space, you're gonna operate that factory 24/7. And so you're looking between 300 and 400 employees. And again, that some of that comes down to how much automation do you have, how much on-site lab testing, what do you have in the front office. But that's what we see as far as developing incentives around a workforce and having to fill that workforce from the local region.
Yeah. Okay. Great. So, Mark, thank you. You get the prize for having the best hat again. They don't know it's a virtual hat, but brilliant. So, you can come back in at the end, and we'll have a little bit of chat between us.
Yes, sir.
It's now time for Marco, who has been previewed on and off all the way through. So I need to do nothing other than ask Marco to explain who he is and what Bottero is, and then to talk about his perspective on the same theme. So Marco, it's all yours.
Oh, hello everyone. Thanks, Finlay, and welcome everybody to this webinar. So my name is Marco Civinini. I work for the Bottero company. I'm working as the strategic marketing for the solar industry. What I want to do, I want to introduce you to my company, to our company, and see how we can be and we can represent an opportunity and a contribution to this manufacturing ecosystem. What is Bottero doing? Well, Bottero is producing solar glass production systems and PV modules assembly factory. And in these two sectors account respectively 60 years history and 20 years history in the field of glass and in the field of PV module assembly line. The way we operate, Bottero is a multinational company. We are, of course, based in north of Italy, close to France, but we have commercial location around the globe, as well as R&D center and industrial locations. So we have a location as well in North Carolina, in the US. We have more than 60,000 installations spread all over the world. And as I said before, we are basically creating a production line for holo glass, for flat glass, and assembly line for modules. The way we're doing, we work as an engineering, as a EPC, so engineering, procurement, and construction company. We are proud to say that in this field, we are a partner of the company Tresun, which is owned by the utility company Enel. And we are building at the moment the European largest photovoltaic panel factory, which will be for the years to come, really the biggest European installation. I keep my finger crossed, but we are waiting to be confirmed and to be awarded for the 3 gigawatt plant in Oklahoma. Both are with HJT technology, so innovative bifacial heterojunction panel. And you see a sketch of the Tresun factory in Southern Europe. Is a 5 lines, completely automated, both on the production side and on the supplying side, integrated and interconnected one with the other. What are we doing? Michael and Mark presented the complex process to build a PV factory. The financing is, of course, a factor. We're not doing this, but whatever comes next, from the size selection to the product specs and the performance requirement, this is what we might be involved from the customer. So I don't want to go through in detail because Mark completely described the whole process of the size selection. The product specs is something that we do together with the customer, and in the performance requirement, this is maybe the signature of Bottero. We can guarantee on a contractual base the output, the line uptime, the line yield. So not only the production, but also some of the basic characteristic to say that that factory will perform at that level under that standard, and we put this in a contract. Our role as an EPC, of course, is basically could be divided into 4 modules. We play. Oh, sorry. We play as a system integrator, so we make sure that all the components which are inside the factory are working into a well unified system. But we can be supportive and go hand in hand with the machine manufacturer to have a co-design when we or the customer may need some technical specification or specific requests, as well as go into a single machine design if the line or the product requires some optimization or some specific request. And at the end, we perform the line automation. So all these components, which may come from different manufacturer, needs to be well integrated, and the line should work in the best possible way. The line automation is something that is at the very end and represent the state of the art of our activity. But at the same time, as an engineering company, we have several other services that we can support both in the solar glass and in the panel production. We can be supportive for any company in throughout the whole cycle, from the feasibility study, so at the very beginning of the process, as well as going into the technology adoption, so using our expertise at hand in hand with a customer to choose what are the best machines to have the performance requested. But at the same time, we can support the company in the startup of the factory, as well as in the after sales and in the service management. So, as I said, we would like to be considered as an alternative to the original and usual OEM module manufacturer, but we could be also an alternative and an opportunity for the solar glass and for the PV module, or as a one-stop shop approach, both solar glass and PV module. And this is what an utility like Enel has done. We are providing a turnkey project to them. We do the startup support, and we have done the operation and management of the complete project for the 3 gigawatt factory at the moment in Southern Europe. But we could be also an opportunity and added value, or for an investor for the same activity, or as well as for an OEM module manufacturer, we can provide a turnkey project, but we can also perform assessment or refurbish or upgrade on existing manufacturing line. I talked about the glass. And in terms of sustainability, let me just go through a couple of calculations I made. I think everybody's talking about cell and, of course, in module manufacturer, but there's a factor which represents in weight 75% maybe of the total weight for each module. This is the glass. A 1 gigawatt module production line has a consumption of more or less roughly 100 tons of glass per day. And if we pack this 100 tons glass per day into a 2 tons package, these are covering 2,000 square meters each day. And if we are figuring out that we maybe need 4 weeks stock for each gigawatt production, the total surface occupied is equivalent to a football field, 56 square meters, which is around a football field. On the other side, the sustainability in terms of carbon footprint, 99%, I would say almost 100% of glass is coming at the moment either from China or from the Southeast Asia, which is a mere 15,000 kilometers or 9,200 miles away from US on average. And I calculated the carbon footprint of a sea freight vessel, which is 12 grams CO2 per tons per kilometer. And the calculation is that every day we are polluting the air with 18.75 tons CO2 for each gigawatt module production that we're doing. Not considering, and I think, Michael, you mentioned that the carbon intensity in those countries, Vietnam, Malaysia, Indonesia, China, is roughly between 40 to double, say almost double what we may have in US. So imagine the carbon footprint are not having at the moment a factory of glass, solar glass in the US. Let me just finish with that. That consideration, that was an article which came up in Nature, which says if we would be able to bring the manufacturing back on by 2035, we would have a lower greenhouse gas and a lower energy, respectively, minus 30% and minus 13% to the same situation as in 2020. So imagine how important it would be to reconstruct a manufacturing environment in US in this solar market. This is what we can contribute, and this is what we will be helpful. Thank you very much.
Oh, thank you, Marco. Excellent. So just one quick question before we go into just some last few minutes of chat between us all. As you've gone through the loop already with the new facility in Europe with Risan, you know, the timing is really good, I guess. There's a lot of reliance I can see at the moment of the US on Europe and European equipment makers, European material suppliers. When you were building out the facility for NL in Europe and in Italy, was that relying a lot on like a European supply chain? Is that saying how important is the European aspect right now in the US when it comes to getting equipment and making factories?
I'd say, luckily, the European industry, maybe contrary to the US industry, maintain a certain level of technology. Not everything has been offset to China. So laminators, for instance, could be supplied from Germany, notably. There are still some machines for which the center of technology is still China. Cell cut, for instance, or stringers might be. There's a growing interest in these machines, so cell cut, for instance. So there are new companies coming up. Germany is making a huge effort. France is making a huge effort to build a complete supply chain. There's a combined effort as well. I know there's maybe a joint investment in joint means US and Germany investment for a cell factory in Germany, which won't be at the beginning for the solar market, will be for the automotive market. But we know that this is also part of the ecosystem, so it could be that we may have a large solution for that. I heard about something regarding cells in France. What is also strange, both in Europe and in the US, there are no rumors. Yeah, there are some projects for glass, but not as expected. US is expecting 85 or 86 gigawatts module production announced up to in the next 3 to 4 years, more or less. And there's no glass supply at the moment, unless we rely on China and Southeast Asia. So let me stress this point. Of course, sales is paramount. Rebuilding the manufacturing capability in terms of skills and labor, but do not underestimate that glass will always be a factor and is very complicated logistically speaking. And it could be also a risk factor because the same source of cells is the source of glass, and the same risks which happens to be in the cell market are those who may happen also in the glass market.
Yeah, okay. Thank you, Marco. So we just have a few minutes left, and we can welcome back just Michael and Mark for a minute. So thanks everyone. We've kind of touched on hopefully a number of challenges and hopefully more opportunities than challenges. So I'm just going to ask a kind of broad question to each of you on the same kind of topic here. Imagine we're 18 months down the line. What is success in terms of building sustainable solar manufacturing in the US? Obviously, this is a long-term project, but I think everyone really needs to say, like, 18 months from now, what would a kind of successful start look like for low carbon sustainable manufacturing in the US? Michael, what does that initial success look like?
So the metrics that I'm really looking for, Finlay, are we have 2 to 3 companies who have broken ground or completed construction on wafer fabs in the U.S. And as you know, there are a number of seasoned companies looking at this. The other is that the polysilicon producers have gained enough confidence in demand for low carbon poly that they are beginning to move forward with capacity expansions in low carbon polysilicon. It is the highest capex, kind of one of the most challenging elements of the supply chain, and the risk of Chinese overcapacity is always a threat, to pricing stability. That said, those will be the markers that we really have decided that there is a segment of this industry that can sustain itself on sustainable low carbon manufacturing in a competitive way, and that growth can then continue in a linear way. And I think all my colleagues would agree. We're in a situation right now where we're in a transitional phase, right? All the growth in the last decade has happened in China, a little bit in Southeast Asia, which is very much overlap there, and we've got to make a lot of solar. And so we are in this transition period where we are trying to grow and green the solar supply chain, even as we keep up with demand. So this will be a process, and no one should expect that 18 or 24 or 36 months, the US or EU is completely independent in PV. That's not really the goal. The goal is create enough domestic manufacturing that people have choices, and those choices start to change manufacturing behaviors globally. And so producers in high carbon markets start to pay attention and think about how they do business.
Yeah, just a quick kind of yes, no. Do you anticipate there being changes or tweaks in policy over the next 18 months?
I do. I anticipate that the reach of the Uyghur Forced Labor Prevention Act will continue to widen. I think they will continue to push it upstream, and scrutiny of further upstream products will continue to grow. And with that, I will say, I think the more sophisticated Chinese manufacturers are really looking for how they continue to serve global markets, perhaps in a different way than they have been doing. And so I do think we're beginning to see this demand for better solar change business practices elsewhere in the world that will help drive decarbonization, and that's a good thing.
Okay.
And I agree with that. And that's not just going to be with solar. The Uyghur Forced Labor Prevention Act, it's going to extend to batteries here as well. So you're going to see it across the board in the clean energy space.
Yeah, and I think there's actually scope to play around an awful lot with the forced labor or unacceptable labor. You could make small tweaks very quickly to encompass an awful lot of Southeast Asia, if need be, as opposed to this, originated as being a Xinjiang issue. But you could quite easily see that extend, if need be, to exclude other countries at the drop of a hat. Anyone that's been traveling around countries in Southeast Asia, the whole Western world, without going a little rant here, specifically targeted country after country of low cost labor where people were working for pennies to make product cheaper and cheaper over the last 50 years. So there's a whole audit trail of seeking out the lowest cost manufacturing at any cost by the Western world. So it's not difficult to go back and pick out country by country purely on that basis of unacceptable working behavior. I said I wasn't going to rant. I'm going to stop. Mark, 18 months from now, what does success look like with sites being new facilities being built across the US? Is it a case of new cell and module facilities in a minimum of 6 different states? What's a success in 18 months?
So I mean, right now, the way CEA is tracking a lot of these announced projects, which I think the number is above 70 right now at the moment. Some of them are going to be perpetually in development. They're just not gonna get there. Obviously, the module factories are kind of the lowest hanging fruit, easiest to implement. You're gonna in 18 months, you're gonna see a lot of those come that are gonna make it. A lot of those coming online, but then kind of like Michael alluded to, is that their continued success beyond that 18 months or 5-year time frame is getting that supply chain domesticated, and kind of the tough parts of that, as you work up the chain, is the glass and the cells. And so the cell factories take, if I'm saying, that a module factory takes 9 months to a year to develop, the cell factory can take up to twice that. And it's equipment lead time, it's complexity of the building, the chem bays, all that sort of stuff, and a clean room, dry room, and so you're going to want to see in that 18-month time frame some critical mass around some of the announced cell factories being achieved. Walls are up. Equipment's going in, clean rooms are being installed, and you're going to want to see appreciable progress there, and you're going to want to see some more. And in that 18-month time frame, you're going to want to see some more announced ingot and wafer facilities. I mean, there's a couple that are out there now, not necessarily under construction yet. You're going to want to see them starting to get closer to that, and if you have that, I think we're on a really good trajectory to have the domestic landscape that we like to talk about and plan for. But again, the reality across the time scale that we sort of see is that if you're a module manufacturer, you're actually probably on a 6-year journey to completely domesticating your supply chain with everything that you're putting into the module.
Yeah, I think you're right. It's I always thought that if I was really serious about doing something, I wouldn't tell anyone, and I wouldn't have an announcement to the world about my strategic plans. So I always have hope that the most serious ones no one knows about, and I really hope I don't know about the really serious money going in to do things.
Yeah, I mean, I tend to agree with you. I mean, marketing and sales has its place in the world, but if you're trying to get things done, and again, putting my chief operations hat on, you don't necessarily want people to know exactly what you're doing or who's doing it. I mean, that's where we get into project code names, and where CEA plays a major role in developing some of these factories. Is you don't really know if you're dealing with us on the government side of things, for example. You probably know the provenance of who our customer is, but you're dealing with me and our director of government affairs, as opposed to the entire entity of the person that's actually going to own and operate the factory. So, one of the areas that's really important is the driving up real estate costs. If somebody knows that, giant company making solar factory down the road, you're going to have 7 or 8 guys trying to get in on that deal and increase the cost of the real estate, take longer. And then so that I have a little bit of inside information into some of these factories because we're working on them at CEA. Is the really, really solid ones that are out there aren't running around with big things on LinkedIn and things on their website. There's nothing wrong with that, but there's definitely a middle ground of a modest approach to how you approach promoting your factory project.
Yeah, I tend to agree. So finally, Marco, 18 months. What is success in your eyes? There being an awful lot more glass production facilities under construction.
Well, for sure, there will be. Although a glass factory may have, let me say, 18 to 24 months cycle to be operating even more. So it will be a longer scale on that factor. But let me say something. So what I would like to see in 18 months in Europe, especially, to have a consideration that we need to have a low carbon footprint using European-based manufacturing, not the Chinese one, which is more or less the way we in Europe we like to do this ecological turnaround. And in US, maybe to have a confidence that this won't be the second bubble after the one happened in 2009, 2010, with a heavily subsidized market. And then when the subsidies ended, the market just depressed. So this is a serious issue. This is a serious a trend and wave that is, of course, pull from the political point of view, but is also something that we have to do. So this is a market which is solid, a market which is important to be developed.
Yeah, I mean, it really should work because nobody's talking about there being the necessity to take a technology risk. It's entirely logistics in making money in logistics, making this happen. No one's saying there's a necessity to introduce an unproven technology as being an essential requirement to go into the market. So I'm probably going to have to draw a line at that point because we're already over the 1 hour mark. And, thank you for those that have stayed on. And hopefully even the people doing the recording, I apologize again. I'll just keep apologizing for going over the hour. But before, I've just got a couple of slides I wanted to show that I'd like to just fly onto for 1 minute because all of this is going to be spoken about ad nauseum. And some of our, in fact, probably everyone here is going to be there and talking and saying an awful lot more about this 2 days we have in the San Francisco Bay Area, our PV Celtech USA conference, so 3rd and 4th of October. There's a host of speakers that I can't believe I'm looking at them all, and that's just not me looking at me and me being modest. This is absolutely brilliant. I like to say it is the stakeholders that are going to matter for building, for what's going to happen in solar manufacturing in the US, but an awful lot is going to be about what are the challenges and what's going to have to get tweaked. And I did say policy, and I do think there will be policy changes because you never get these things right first time. So to Marco, to Mark, to Michael, to all the M's, thank you hugely for taking the time. I know we didn't go through all the questions, but we will distribute those afterwards. Thank you everyone that's been on the call for the last hour and typed in the questions. And I'm sorry if I've not asked them. I find it hard to multitask and read on the 59th minute of questions coming in. But again, Mark, Michael, and Marco, thank you.
Thanks a lot.
Been a pleasure.
Yeah,
Thanks.
And great, and thanks everyone, and hope to see as many of you in the PV Tech at the start of October. Thank you very much.